Think about like that co-pilot agent or coding agent. This is the science agent. John?
Thanks, Satya. I'm John, chemistry product lead for our science platform. Today, I'll show you how I lead a team of agents to make a discovery for immersion coolants. These are an interesting line of research for cooling data centers. Unfortunately, most of them are based on PFAS, or forever chemicals, which are harmful for the environment. So, how could I discover a better coolant? I'll show you 3 steps today: reasoning over knowledge, generating hypotheses, and running experiments, all in an iterative loop. Let's dive in. My first step is to conduct research. So I want to be up to date with the latest knowledge on this topic. So I'll start by asking about coolants and their properties to help me identify starting candidates. The platform uses a network of agents that reason over scientific knowledge in both public sources and your trusted internal research. Behind the scenes, it uses a knowledge graph to provide deeper insights and more accurate answers than we get from LLMs on their own, which can struggle to connect the dots. This process will take a few minutes, so let's skip ahead. And what we see here is a summary on the left and a comprehensive report on the right, covering the state-of-the-art in coolant research with links throughout to citations for trusted research. Now, I can validate these findings and iterate if I choose before moving on. But our goal today is not just to reason over knowledge. We want to make a real coolant discovery. So we need to move on to step 2, which is generating hypotheses. So I am going to ask for a plan specific to my investigation, informed by this research, knowing, for example, that I should target a specific boiling point and a dielectric constant that won't fry my electronics. So we'll submit that. Now, my team of agents is working to build the right workflow. Now, you'll see, I didn't specify what methods to use or write any code. Microsoft Discovery handles it all for me. The agents can use tools and models from Microsoft. They can integrate open source or third-party solutions, or even ones from my own organization. And I can always adjust this plan, either adding additional steps or changing the criteria so that I'm always in control. And if we look right here, we can see the plan that my agents returned. It starts with a generative chemistry step here, where it creates millions of novel candidates that are more likely to meet my criteria. And then it uses AI models to screen these down quickly. And finally, we use HPC simulations for validation of our findings. And you know, as I look at this, I like this plan. It looks like a good approach, so let's go ahead and run it. We click proceed right there. And with that, we're in step 3, experimentation. Microsoft Discovery executes this full plan, choosing and managing the best HPC resources in Azure. And in the future, it will also integrate our advances in quantum computing. We can see here now the Discovery agents working together in real time, driving all of these intense computations. With traditional methods, getting to a short list of candidates could take months or years of trial and error. Microsoft Discovery can compress the time to days or even hours. So let me show you the final results of the process. These are the set of candidates that Microsoft Discovery has identified for PFAS-free immersion coolants. So now I can analyze these results to decide if I'm ready to head to the lab or if I need to run another iteration. And if I just take a look at a couple of these, I can see that, indeed, yeah, the boiling points are in line with my expectations and the dielectric constant is great. So this is very promising. But I know what you're wondering. Did we actually make a discovery? Well, this is not just a demo. We really did this. We took one of the most promising candidates and synthesized it. They didn't let me bring a new material unknown to humans onto this stage. But I've got this video from the lab. So we can see there my coolant, and we dropped a standard PC in it, and it's running Forza Motorsport. And it is keeping the temperature stable with no fans. It's literally very cool. We found a promising candidate for an immersion coolant that does not rely on forever chemicals. Imagine using Microsoft Discovery across domains, designing new therapeutics, new semiconductors, or new materials. It worked for us. The next great breakthrough is yours to discover. Thank you. Have a great build. Back to you, Sachin.